Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, I recently learned that approximately 50% of men and 30% of women in the US alone will develop symptomatic heart disease. And this is a similar story all around the world. And it can be expensive to treat, and complications can arise from invasive diagnostic procedures. But I recently discovered a company called HeartFlow, and they're using non-invasive technology to help determine who is at greater risk of a cardiovascular episode. So I invited Charles Taylor, co-founder, chief scientific officer and member of the board of directors of HeartFlow, onto the podcast to learn more about the company, but also his story, what put him on this path. And thankfully, he said yes. So buckle up and hold on tight as I beam your ears all the way to California, where you can join me and Charles in conversation now. So a massive warm welcome to the show. Can you tell the listeners a little about how you got here, share your origin story, and just introduce the listeners to who you are and what you do?
Well, it's great to be here, Neil. My name is Charlie Taylor. I'm founder and chief scientific officer at HeartFlow Incorporated. Before starting HeartFlow in 2010, I was a professor at Stanford University in the schools of medicine and the School of Engineering. And really, years before that, I'd started working with computers to model physical systems, create computer models for different industrial applications like aircraft engines and satellites and a variety of other problems. And I went to graduate school at Stanford to do my doctorate. Happened to see a flyer on the wall that said a talk was going to be given that afternoon called Blood Flow in Your Health. I was inspired. I went to it and met our new chief of vascular surgery at Stanford, who convinced me about the opportunities working between engineering and medicine to understand the leading killer, heart disease. That was about 29 years ago or so.
Wow.
And have been working on this problem ever since, first at Stanford and then at HeartFlow.
Wow, what a great story. I love the switch there as well. And of course, fast forward to 2022, you're now the co-founder, chief scientific officer, and a member of the board of directors at HeartFlow. But there will be people listening all over the world hearing about it for the first time. So could you tell them a little about the kind of problems that you're solving and what makes you different from other approaches or solutions out there?
You know, I had a realization, it's actually when I was in graduate school, that the information, the data available to physicians, in that case, it was surgeons, vascular surgeons planning treatments for patients. What they didn't know, they didn't have the ability to be able to predict if they did something, whether there would be a benefit. And as an engineer, I was used to doing that. You design something, you design it, of course, in the old days, it was on paper and blackboards. And nowadays, everything is designed that we use, practically speaking, on computers. But you'd have the ability to design something, simulate it, see how it works before you actually build it. And what I realized is that in surgery, it was more of an empirical discipline where procedures were performed, you would see if it worked. And then if it didn't work, you'd do something else. But of course, the consequences of doing that for a patient can be significant. So the realization I had is if we could combine medical imaging data about the patient's anatomy together with computer models and simulations, we could predict how it would work. If a patient had heart disease and they needed to be treated, we could predict whether there would be a clinical benefit before the patient was in the operating room or in the cardiac catheterization lab. So that was the genesis of the idea. And that was quite frankly, what we worked on at Stanford was a radically different approach to medicine. Quite frankly, it was about predicting outcomes using these modern imaging computer tools to be able to plan procedures. And that was really the starting point of the genesis of the idea for ultimately what became HeartFlow. And the particular problem we focused on at HeartFlow is the leading killer. It's coronary artery disease. Patients who get heart disease involving atherosclerosis in their coronary arteries that provide the blood supply to the muscle of the heart. When they get it, it's often difficult to diagnose and difficult to decide what the best course of treatment would be. Should a patient get medicine, tablets? Should they get a stent? Should they go to bypass surgery? And it is a problem at the core of cardiology. And what we realized is that there were not great non-invasive techniques in order to do that. And that's what we built starting in 2010 at HeartFlow.
And before you came on the podcast today, I wanted to do a little bit of research and find out a little bit more about the situation at the moment. And I read that approximately 50% of men and 30% of women in the US alone will develop symptomatic heart disease. So can you expand on that scale of the problem out there?
Well, it is massive, and it's not just a problem of industrialized, it's not just the first world problem. It's a problem that we see everywhere around the world. It's the leading killer. It's a third of global deaths. And this has actually remained true even during the period of COVID. Heart disease was still the leading killer. As we age, of course, we have different problems and manifestations. And one of them is that almost all people over a certain age have some atherosclerosis in their arteries in their body. And the coronary arteries are the ones that put a patient at risk of heart disease. So it's very, very common condition. Again, men and women, kills more women than breast cancer. What we aspire to is the possibility with better diagnosis, better diagnostic tools, better information about how to plan therapy, again, whether medicine, stents, or surgery, that we can make a dent and maybe think very boldly that as we go forward in the future. And I think when both of us were young, this was just fanciful to think about doing a 3D image to see everything inside the body. It was kind of this Star Trek science fiction. But the ability to be able to do that and create the level of data and information about what our arteries look like inside, whether we have disease, was incredibly powerful. And it is the foundation of HeartFlow as a company, is the patient image data. In our case, we get cardiac CT data, which is a standard scan. In the UK, it is the frontline test for patients with chest pain. It is the first imaging study that is recommended by NICE. But once the data is acquired, the challenge is that it's really hard to interpret in many cases, especially if a patient has disease or calcium. And there really is no ability, to get information about physiology and blood flow from the test itself. So that's where the techniques that we developed come in. And it's a pretty cool tech story. I mean, I'm an engineer, I have a Ph.D. in engineering and also a degree in mathematics. And it's a really cool tech story because the story behind it is we take image data that is acquired with, CT scanners in hospitals. We take it out into the cloud. Our service runs in Amazon Web Services, but then we use AI. We use deep learning. We are a deep learning AI company at our core. In fact, we've had these techniques in our cleared products for more than 5 years. So we've always been that. And once you use AI and you extract information about the anatomy, then the next step is to have people inspect and correct, what's called supervised learning. And after we've done that, the great benefit of that is that every case we do, we actually have information that can help us get better in the future. So you continuously have the ability to learn, to gather information, and to get better and better over time. And, we all get better more times we do things. Doctors get better the more CT scans they read. But we can do this with computers at a scale that's just not conceivable, because we can have recall where we can have hundreds, thousands of patients informing a model, informing an algorithm that is kind of built into the algorithm. So it's a really neat story. And in the end of the day, we create this a 3D model of the patient's coronary arteries. We simulate their blood flow, and we determine if the disease that they have is limiting the blood supply to the muscle of the heart. If it is, then there's an indication for often more aggressive treatment. Maybe the patient needs to go in for a stent, or they need to go into surgery. If the doctors get what they call a blue HeartFlow report, it indicates that the patient may have disease, but it's best managed with medicine. And that's the key information. But it's at our core, it's engineering, it's computer science, and taking advantage of some of the most modern technologies today available to us.
And am I right in saying that this technology not only saves lives, but also saves lives because patients are not at risk from complications during things like invasive diagnostic procedures? Because you're essentially removing that, aren't you?
Yeah, well, we're reducing the number of patients that need the invasive tests. what was surprising to me when I first started working on this and understanding the problem, with the data that was out there was available, I was struck by is that roughly 75% of patients that at that time were going into a cardiac catheterization lab for an invasive assessment and maybe procedure, about 75% of those patients either did not have significant enough coronary artery disease to really warrant an invasive intervention, or they had disease, but it wasn't limiting the blood supply to the muscle of the heart. So you're doing an invasive diagnostic test on 100 patients to find those 25 that really needed to be there. And what I thought is that, we don't have to have a perfect non-invasive test, but because it's non-invasive, if we could accurately identify patients that could be deferred, that could go right to medicine, and they don't need to go on to an invasive procedure, it's much better for patients. If to find that 75% of patients that don't need to be in the cardiac catheterization lab, it's much better to find them non-invasively rather than getting their arm, their wrist, or groin punctured, have a catheter snaked into their heart, because there is risk associated with doing that. The other side of this too is it's cost effective, because invasive testing procedures are expensive, much more expensive than doing non-invasive tests. So if you can, for the majority of patients, identify those that really don't need to be there, identify the ones that really should be there, then that's great. That's great for healthcare systems as well as individual patients. And the one other side of the story is there are also a large group of patients that are completely missed. With existing diagnostic tests, they get a negative test and falsely reassured that they're okay, yet they might have life-threatening coronary artery disease. In standard practice, we would find the 25% that really need to be there, but we're also finding additional patients that were being missed that really had often life-threatening coronary artery disease, were being missed by other tests and really needed, to go in there and into that cardiac catheterization lab for an assessment. So there's, been, on both sides of the equation have been advances that we've been able to make.
And from my point of view here on the outside looking in, it's just incredible, and also incredible for patients. But I'm curious, how has it been received by the medical community? What kind of feedback have you received there?
Well, when I was first started thinking about this, and when I was a professor at Stanford, I was a little worried that it might be received as just too far out there, these fancy computers sort of thing. And it's been really the opposite experience that I've had so far. I think, physicians, especially the ones that are experienced, they understand the challenges that they face. And I think oftentimes they've been very eager to get better information and better tools. So I have to say, I've really seen a lot of enthusiasm for this type of information, for getting non-invasive data. In the US, most of the top heart hospitals use our product. In NHS, I think we're over 70 hospitals in England, NHS England. So there's a lot of enthusiasm for this type of technology, and mostly for the information we're providing. It's not just about tech; it's about using tech to be able to provide very valuable information that helps physicians care for their patients. And I think they've been pretty happy about it. The other side of that story, though, and we've been very deliberate, and perhaps this was related to our academic roots. In the very beginning, when we showed some of these results, people would say, well, that's science fiction. You can't possibly do what you say you're doing. And we would say, okay, we'll prove it. And these patients that we're going to go to cardiac cath, you're going to measure pressure and whether the disease is limiting the blood supply to the muscle of the heart. We'll do it also non-invasively, and you can compare the results. And we've done that over and over and over again. And now, I'm really proud of the fact that there have been over 500 scientific clinical papers published in the literature, medical literature, about our technology. And we've constantly and consistently leaned in when there are evidence gaps and said, okay, let's go find out, does it help this group of patients? Let's find out. By leaning in and answering some of the questions that physicians have had, I think it really helps with adoption of this type of technology, because it is radically different than what was done before.
It's incredibly cool what you've achieved here. And I was thinking before you came on the podcast, now so many people have got like smartwatches and wearables, etc., that have continuously monitoring heart rates, exercising up people, counting steps and sleep patterns, etc. Do you think that technology is driving a more proactive approach to healthcare now rather than that previous reactive healthcare that we both grew up with?
I think so. And that's going to be a really good thing. Yeah. And because a disease like, many diseases, and this is true of heart disease and also cancer, they're eminently preventable, they're eminently treatable. And a large part of this is that we have the responsibilities to care for ourselves. And it's hard to do, in modern life to always, do the best in terms of eating and exercise and the like. But the better, the more patients are engaged in their care, the better off they're going to be. And, that's been proven in a number of studies. There was a large study in the UK called Scott Hart that demonstrated that if you image the coronary arteries, image the heart, and you saw whether there was disease present, that patients, you could, by just that act alone, by using this CT scan to look at the coronary artery disease, you could reduce the risk of death and heart attacks. And one of the main reasons for that was that physicians knew the disease was there, but so did patients. Patients were, prescribed perhaps more medications, or they were more compliant with their medication. That knowledge is power, and that can help patients do better. And that's what we see also with our technology, because when a patient sees it, they see the results, and hopefully we catch it before it's too far along. But they can be a big part of the solution to the problem that they have, and that's powerful. And I agree with you. I think patients are becoming much better informed. We have better ways of looking at their disease. But a problem, like, most people don't know it. If most people have it when they get over a certain age, most people don't know it, and they don't know how severe it is. And this is another problem where often the first symptom of a heart disease is a fatal heart attack. And that's something that over time obviously has to be addressed. This shouldn't be the case. It should be possible to take a disease like heart disease and significantly reduce the rate of premature death.
And as for yourselves, what excites you about how technology will continue to transform the diagnosis and management of coronary artery disease? Is there anything that makes you particularly hopeful or even excited?
I think probably everybody in many times of history feel like they lived in a special time. And we're living through this period of time where it can be very disruptive, and it is changing so rapidly, it makes our heads spin, I think, sometimes. But the possibilities of harnessing that and leveraging that and using technology for good and for tackling some, of the biggest problems, that's really inspiring. There are problems with technology. I think there are also some wonderful upsides, and the people that are building it, I think, obviously have a tremendous responsibility in using it to improve people's lives, which is what we've been focused on.
100% with you on that. Now, none of us are able to achieve success without some help along the way. So a question I wanted to ask you today, is there a particular person that you're grateful towards, or anybody that helped you get where you are today that you'd like to give a shout out to?
There are so many other people that have been involved, that helped me and influenced my career. And certainly this is true of the people that I've worked with at HeartFlow. And when you have a group of individuals that are all working towards a common goal and are really bright and talented, it just makes the job a lot funner, but it makes it possible to make progress at a much faster pace. But, I thought about this, is there one person that really had the greatest influence over my life? And, I've lived at this intersect between medicine and engineering, now for almost the last 30 years. And it was really two people that actually influenced my life. It was, in my career, tremendously. I would not be here today if it wasn't for these two individuals. And first of all is Chris Ahrens, who was our chief of vascular surgery at Stanford, who inspired me, who gave that talk on blood flow in your health, and really inspired me to work as an engineer, to use my skills as an engineer to solve these problems. And Chris was, again, somebody at the interface. You don't make progress at the interface unless you have people that are willing to look at both sides of a problem. And for us, it was medicine and engineering. I'm an engineer who has learned a great deal about cardiology in order to make a positive impact. And so that's one side of it. The other person that significantly influenced me was my engineering advisor, Tom Hughes, who's one of the kind of foremost applied mathematicians and developer of computer technology. And it was really those two individuals, and they were both my doctoral co-advisors, that helped me build a career at the interface between technology and engineering and medicine.
And before I let you go, can you remind everyone listening where they can find you online, contact your team if they've got any questions, or the best starting point for everything?
Yeah, you can find HeartFlow online at www.heartflow.com. And come to our website, take a look at the things that we're doing. And there's ways to contact us, whether you're a patient or whether you're a physician. And really appreciate the time to talk to you today, Neil.
No, thank you. I absolutely love what you're doing here. And the technologies involved as well, from, as you said, artificial intelligence, deep learning, etc., and all these things going on that people don't get to hear about. But I love what you're doing. I'd love to continue to follow your progress, maybe get you back on later in the year or next year and see how things are progressing and the kind of impact that this technology is having. But more than anything, just thank you for sharing your story today.
Great. Thank you. Yeah, thank you for the opportunity to do so.
What a great story of how technology is transforming the diagnosis and management of coronary artery disease. And these are the kind of stories I love sharing on here. Technology making a difference in areas that we don't think about and maybe don't associate with technology. So do you have a similar story, not just in healthcare, in any industry at all, of how technology is changing things, transforming them, or making a real difference in the world? As always, email me, techblogwriter@outlook.com. You can get me on Twitter, LinkedIn, Instagram at Neil C. Hughes. But as always, send me a DM, say hello, don't just hit the follow button. It'd be nice to keep this conversation going. But that's it for today, so I'll be back again tomorrow, clogging up your podcast feed. But until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.